Being the wonderful teacher that I am, I have decided to make y'all a short review video to remind you on how to do some of these derivative things that we haven't seen in a while, so that you can prepare for your test. So the first thing we're going to do is just remember some of the rules. When I look at the first one, if I'm trying to take the derivative of this is a product rule because I have an x in this piece and an x in this piece. So I have to remember what my product rule is. So that is, the derivative will be the first times the derivative of the second. Now this is a a to the x rule, so 3 to the 2x times the natural log of 3, and then times the derivative of the exponent, so 2. So first derivative of the second plus the second times the derivative of the first, which would just be your power rule. So there is a basic derivative product rule. Number 2 is your basic derivative quotient rule. So our derivative would be a quotient rule where we say the bottom log base 2 of x to the fourth times the derivative of the top, which would be 5e to the x, minus the top times the derivative of the bottom, so 1 over x to the fourth times the natural log of 2, all over the bottom squared. So log base 2 x to the fourth all squared. So there's your quotient rule. Now as I'm doing these, keep in mind that I'm just reminding you of rules. I'm not giving you the exact problems on the test, but I'm trying to get you to think in the direction that you will need to for that test. Example 3, I have f of x is cosine x, and we want to find f prime of 3 pi over 4. So when they want us to do this, they're just asking us to plug in. So take the derivative. Derivative of cosine is negative sine. And then if I plug in 3 pi over 4, negative sine of 3 pi over 4, you have to think about your unit circle. 3 pi over 4 is right here. That's a negative square root 2 over 2, positive square root 2 over 2, and that sign is a positive square root 2 over 2. So I have negative square root 2 over 2 because I'm bringing the negative down from above. 4 is one we haven't done very many of. We may have done a few, but it's basically the same thing we were just doing except with implicit differentiation. So we're going to do implicit differentiation and then plug in a point. And I made this one up off the top of my head, so it could get interesting. So if I do this implicit differentiation, I have derivative of 2x is 2. This is a product rule, so I have first derivative of the second plus second derivative of the first. Over here I would have 5y prime and then minus 2y prime, because this would be a chain rule where I do the outside first and then the inside. I'm going to get all my y primes on the left, so I have 3x y prime minus 5y prime minus 2y prime. And I'm going to subtract the 2 and the 3y to the other side. I'm going to factor out my y prime. So I would have 3x minus 5 minus 2y equals negative 2 minus 3y. And then I'm going to divide. So negative 2 minus 3y over 3x minus 5 minus 2y. Now because they're asking us to plug this point up here in, I'm going to plug a 4/5 in for x and 1 in for y and see what I get. So negative 2 minus 3 times 1 over 3 times 4/5 minus 5 minus 2 times 1. So on top I just get a negative 5. On the bottom I'm going to get 12/5 minus what ends up to be 7. And when I work that out, I get 25 over 23. I'm just skipping a few steps right in there, but you could, do the math to get there if you need to, plug it in your calculator, whatever. Number 5, we're going to sketch a graph where dy over dx is greater than 0. So dy over dx is your derivative. Derivative being greater than 0 means derivative is positive, so the graph is increasing. And then d squared y over dx squared is your second derivative, and that is less than 0, so that's another way of saying negative. So a negative second derivative means concave down. So I want to draw a graph that's increasing and concave down. And again, you'll use these ideas for your problem, but it's not your exact problem on your test. Number 6, for what values is this graph concave down? So again, concave down relates to the second derivative. So you have an equation this time, and so we need to use the kind of algebraic steps to get there. So y prime, I'm going to think of this because there's no x on top as negative 2x plus 3 to the negative 1. So my derivative would be 2x plus 3 to the negative 2. And then I'm not caring about increasing and decreasing, so I'm not going to set that derivative equal to 0. I'm going to go on to the second derivative, which would be negative 4x plus 3 to the negative 3. Now I'm going to set that equal to 0, and I'm going to write it as a fraction so I can think about what I'm doing. Well, if you multiply both sides by the denominator, then it goes away. It's 0, and you're like, what's going on here? Think back to what you know about this graph. This is a vertical asymptote at x equals negative 3. So even though we didn't get a place where the second derivative is 0, there's no point of inflection, there is an asymptote dividing up this graph. So I still have to check both sides of it to see whether I would get anywhere being concave down. So if I plug in something like negative 4, negative 4 plus 3 would be a negative 1, cubed would be a negative 1, and a negative over a negative would be a positive. If I plugged in something on the right side like 0, I'm going to get a negative number, negative 4 over 9, so that would be a negative number overall. So this graph would be concave down from negative 3 to infinity. Alright, number 7, especially for Jessie here, Ms. Adams wants to build a fence, or fence in an area next to the school for a garden, so she needs fencing for 3 sides. So the school's going to be one side, we're going to need fence on 3 sides. Mr. Poole gets her 400 feet of fence, and we want to know the biggest garden she can enclose. So you always make the 2 sides that are parallel x. Again, we don't need it back here. And if you had 400 feet of fence and used x on this side and x on this side, you would get 400 minus 2x. We are trying to maximize area, so think about what the area of this figure would be. It's a rectangle, so you do length times width or base times height. So I'm doing x times 400 minus 2x. Well, the way that we find maximums and minimums in calculus is by setting the derivative equal to 0. In order to do that, I'm going to get an easier way to the derivative, so I'm going to distribute my x, get 400x minus 2x squared. Now I can easily take the derivative, so that will be 400 minus 4x, and I want to set that equal to 0. So I think I'm just going to go ahead and erase that a prime and set that equal to 0. Well, I can add to the other side, so 4x will equal 400, divide, and x is going to equal 100. So what that's telling me is my garden is going to have 100 feet here and 100 feet here, so obviously there's 200 feet left here. The biggest area she can enclose is whatever 100 times 200 is, which would be 20,000 square feet. And again, I made these things up off the top of my head, so they're not possibly, may not be the most realistic situation, but that's how you figure it out. You're always coming up with an equation that relates to the figure, usually some kind of geometry, area, or volume, and you take the derivative and set it equal to 0, solve, and interpret your answer. Number 8, just throw in a limit there. Reminder that sine x over x, that limit was 1. So when I have something like this, I can take the shortcut and my answer would be 5/2. But again, if you want to know what's all behind that, go back and look at your notes over that section. Like I said, you won't have this exact problem. You'll have something similar, so you may want to familiarize yourself with that. Number 9, when Mr. Waycaster went skiing at Appalachian Ski Mountain, Marco decided to roll a snowball at him. It began to gather snow at a rate of 75 feet cubed per second. At what rate is the radius of the snowball increasing when the diameter is 3 feet? So this is our related rates problem. And if you think about a snowball, it is in the shape of a sphere. So this will be my radius. And so I'm going to write down everything I know. It's gathering snow at 75 feet cubed per second. That is a rate of change of volume. So dV dt. And my diameter is 3 feet. So my radius is 1.5 feet. And then we want to think about what geometry formula can relate these things and work with these variables. So this would be the volume of a sphere. Volume of a sphere is 4/3 pi r cubed. And so if I take the derivative of that, I get my dV dt. The 3 multiplies in front, which cancels out the bottom, so I get 4 pi r squared, and then the derivative of the inside would be dr dt, because this is implicit differentiation. And then I'm going to plug in what I know. So I know that dV dt is 75, and r is 1.5. I will mention that I usually write down what I'm trying to find, and that was the rate of change of the radius, so that was dr dt. That's what I'm trying to find. That's why I don't have anything for it over here. So I'm going to divide 75 by 4 pi times 1.5. And I'll need to plug that in. And I get 3.978. And again, radius in this case is measured in feet, and the time was measured in seconds, so that would be feet per second. And that's how I do my related rates problem. Again, I write down my given information, figure out what all it is and what's missing, and find the equation that's going to relate all of those things, take the derivative, and then plug in to solve. Alright, the last thing I wanted to review with you is really what we did that video on. And that was looking at functions and talking about whether they're continuous or differentiable, and several of the ones that you had in the sorting activity were piecewise functions. To check continuity, you just plug into what you have. So plug the 4 in for x. So 4 squared minus 3, and 2 times 4 plus 5. So this will be 16 minus 3, which is 13. And 8 plus 5, which is 13. So that right there means that this function is continuous. To check differentiability, you have to do the derivative. So the derivative of the top one is 2x, and the derivative of the bottom one is just 2. But you still plug in, if there's still a place to plug in, you plug in the 4. So this is really 2 times 4, which is 8. So your top one you're getting 8, the bottom one you're getting 2. That means it's not differentiable. The place where it's meeting, it does meet, but it's meeting at either a sharp corner or a cusp or something like that. It's going on. This one obviously is a parabola and a line. So you've got a parabola that could be doing something like this, and a line that could be doing something like this or something like this, making a sharp corner. When you actually think about the two graphs, you can get specific on that one. But hopefully this helps you out and you're able to do well on the test tomorrow. Good luck, and study hard.